Hello everyone, welcome to my channel. Today we are discussing about structures of menus. So menus are nothing but it is a set of options presented to the user of a computer application to help the user find information or execute a program function. So menus are common in graphical user interfaces such as Windows or Mac operating system. And menus are effective because they utilize the more powerful human capabilities capability of recognizing rather than the weaker capability of recall. That is, humans can recognize than recalling. So working with menus reminds people of available options and information that they may not be aware of or they might have forgotten. So here coming for the structures of menus, menus are classified into 6 types. So coming for that is menus vary in form from very simple to very complex. So they may range from small dialog boxes requesting the user to choose between one or more alternatives. So here the first type of menu is a single menu. So in this simplest form of menu, a single screen or window is presented to seek the user's input or request an action to be performed. For example, whenever we are playing a game, the choices present may be novice or intermediate or expert. For example, choice 1, choice 2, choice 3, like novice, intermediate or expert. So the user has to choose any one single choice here. Or whenever we are browsing some data, we want to stay connected to the network or we want to disconnect. So two choices we are there, either connected or to disconnect. So here in a single menu, the user has to choose any one single choice. That is, the user need only consider the immediate consequences of the item being chosen, and the need not be concerned with any other additional system menus. So we say that a single menu may be iterative if it requires data to be entered into it, and this data input is subject to a validity check that fails. So the menu will then be represented to the user with a message requesting re-entry of the valid data. For example, this is an order screen here, my order, and here the user can order any one choice here among all the three, anything he can order. So that is about single menu. Sequential linear menus, these are presented on a series of screens possessing only one path. So the menu screens are presented in a preset order, and generally their objective is for specifying parameters or for entering the data. So sequential path menus have many shortcomings. So as a long sequence may become tedious as menu after menu is presented. For example, if you choose any one choice here, it may lead to the next page of submenu. So in the next submenu, again we may choose certain choices, and then it may be having the next succeeding menus. So here we should have a path. When from the third menu I may want to come back to the second or the third, then it becomes a tedious job, we say. So this is sequentially, that is from one menu set how I can move to the next screen, possessing that there should be only one path to access the menus. Then the third type is the simultaneous menus. Instead of being presented on separate screens, in simultaneous menus, all options are available simultaneously. That is, like this, all the alternatives will be present parallelly here, like not like the sequential linear menu. So here problem with simultaneous menus are that for large collections of menu, alternative screen clutter can easily occur. As the number of choices increases, the screen may look awkward. It might clutter easily. And screen paging or scrolling may still be necessary to view all the choices. So presenting many menus, dependencies and relationships on a screen, especially if poorly indicated, can also be very confusing. So here if you are if you are including many menu choices, then it may clutter the screen. See, for example, if you take our Windows 10, we see many choices like this. So this is an example for simultaneous menu. Many options are cluttered on the screen here. Next is the hierarchical menus. So when many relationships exist between menu alternatives and some menu options are only appropriate depending upon a previous menu selection, a hierarchical selection is the best one, we can say. So here a hierarchical structure results in an increasing refinement of choice as menus are stepped through. So it might be arranged in a inverse tree, leading to more and more branches as one move downward through it. So here the hierarchical menus are arranged in the form of a tree structure which has the breadth and the depth. So here common examples of hierarchical design today are found in menu bars with their associated pull down menus. So here the disadvantage of a hierarchical scheme is that the defined branching order may not fit the user's conception of the task flow, and if the users are not familiar with hierarchical menus and are unable to predict what sub-options lie below them, a particular choice, they may go down with wrong paths and find it necessary to go back up the tree to change a choice or perhaps even return to the top level menu. So the order and structure of branching in a hierarchy is preset, and the normal order of flow is one way, that is top down. So that is the reason here there may be some problems encountered if the choices are not properly placed on the breadth and the depth of the tree, that is the branches of the tree. So example, if you see this main menu, we have here information menu, protocol input menu, protocol validation menu and file menu. Within this branch you have again new protocol menu, existing protocol menu, and this in turn is having a sub branch, hierarchical, elective menu, etc. It means that we have 3 levels here, we have 4 levels here, that is level 0, level 1, level 2 and level 3. So if this is properly not, if the choices are not properly aligned here, then there is a chances that we may go with a wrong path and end up with some wrong decisions if the menus are not properly arranged in a proper depth and the breadth. So the next type of menus are the connected menus. So connected menus are network of menus all interconnected in some manner. So movement through a structure of menus is not restricted to a hierarchical tree, but it is permitted between most or all menus in the network. So a connected menu system may be cyclical with movement permitted in either direction between menus, or it might be acyclic with movement permitted in only one direction. These menus also vary in connectivity and the extent to which menus are linked by multiple paths. For example, if you take here how to access the Windows Explorer here. For example, we go to the start button, from there we choose programs. From programs it is connected to accessories, and from accessories we are choosing the Windows Explorer. So here this menus all are connected. Okay, so there is a network, this is a network of menus, they are arranged in some manner. So the movement is through a structure of menus. There's no restriction like what we see in the hierarchical menu. So what should be the breadth, what options has to be put in the breadth, and what should be in the how many depth. should be there. So this is an example for concatenated menus. These concatenated menus are nothing but these are examples of connected menus, cascading menus. Cascading menus are examples of connected menus. Then the last type of menus are event trapping menus. These event trapping menus provide an ever-present background of control over the system state and parameters while the user is working on a foreground task. They are in essence a set of simultaneous menus imposed on hierarchical menus. So in a graphical hierarchy, if you consider, the menu bar and its pull down is an example for event trapping. So in event trapping menus, generally they serve one of the three functions, that is, they immediately change some other parameters in the current environment, or they may take the user out of the current environment to perform some operation on the without leaving the current environment, or they may exit the current environment and allow the user to move to the totally new environment. For example, if you take MS Word, if I am editing a document, I want to change the font of the text, or I want to I want to make the text bold, means from the current working area I will select the text and choose the options present in the menu bar. I am leaving my current environment, I am going to the new environment. There I am selecting some parameter there in order to perform the operation. So that may happen. So this is nothing but an event, we say. Whatever option I am choosing there, by right clicking my mouse button or by selecting through my mouse button, I can perform that operation on that particular text. So that event is happening whenever I click the mouse by selecting the text. Or as the best example is the paste operation. The paste operation in a word processing application is an event trapping menu. So where I want to paste, just by by dragging and dropping, I can paste the whatever I have selected in the current working environment. So if I place the cursor on that paste option, it will show how my paste will look like. So that is an example for event trapping menus. So next, coming for functions of menus. So from the user's perspective, a menu can be used to perform several functions to navigate to a new menu. So here one function of a menu is to navigation to a new menu. Navigation means each user selection causes another menu in a hierarchical menu tree to be displayed. So whenever a user selects a menu, he will move to a new menu. The purpose of each selection is to steer the user toward an objective or goal. So the user is selecting some menus in order to achieve his objective or the goal. So the selection errors may lead the user down wrong paths and the cost, time and perhaps aggravation, but these errors are non-destructive and usually undoable. So here now whenever the user is selecting some menus to perform some operation, if the selection leads to an error, then it may lead to some wrong paths and the cost involved also might be more. But anyhow, we cannot avoid such kind of errors. So while navigating, while moving to a new menu, the user should choose the right choices to achieve his objective or the goal. Next is execute an action or the procedure. So a user selection directs the computer to implement an action or perform a procedure. That is, the action may be something like opening a file or closing a file or copying a text or sending a message. So in some cases, execution may only occur after a hierarchical menu tree is navigated. In other cases, actions may be performed as successive hierarchical menus are encountered and traversed. So accidental selection of critical irreversible actions must be prevented in interface design. So here, whenever the user first navigates to a new command, then the user executes an action by clicking on that particular menu. That action will be performed, but some of the operations might be irreversible. Undo is not supported. So the user has to be very careful in selecting or performing some actions. Next is the displaying the information. So the main purpose of selecting a menu choice may be simply to display the information. So the user may be searching for specific information in a database or browsing the web. So the user's focus is primarily on the information desired and less on the selection functions. So here the content material and the user's interest will determine the paths followed. So user may spend some considerable amount of time and effort for understanding and processing some of the uncovered information in order to display using some of the menu choice. So wrong turns in the process will again cost the time and aggravation. So but these errors are non-destructive and they are also usually undoable. Next is the data or parameter input. So each selection specifies a piece of input data for the system or provides a parameter value. So data or values may be input on a single menu or spread over a hierarchy of menus. So here the user's focus is primarily on the information being provided and again less on the selection function. So these selection errors can easily be corrected if detected by the system. So here these are some of the functions of menus. The four functions are: one is navigating to a new menu. Once the new menu is selected, it has to be executed, and once it is executed, then the information will be displayed. To get the proper information, the user may need to enter the data or some parameter as an input, so that he should not be avoided. That is, he should go in a right path to get the required information to achieve his goal or the objective. So coming for the contents of menu. So a menu consists of four elements: its content, its title, its choice of description, and its complete instructions. So coming for menu context, a menu context provides information to keep the user oriented. So here this kind of information is critical in complex or hierarchical menu systems where loss of position or disorientation can easily occur. So feedback is necessary that tells the user where they are in a process, what their past choices are, or possibly how much farther they still have to navigate. So whenever a user is navigating through the menus, sometimes he may forget where he is. So the system should provide him a necessary feedback telling him where he is now currently and what was the past choices he has chosen, how much farther still he has to navigate. So human memory being what it is, where one is and how one got there all is easily slip of consciousness. So verbal linkage and spatial linkage or both may be used to provide navigation feedback. So what is this verbal linkage? It involves providing on the current menu screen a listing of choices made on the previous menus that had led to this position. So spatial linkage can be accomplished by graphic methods. Each succeeding menu screen can be displayed overlapping the previous menu screen. Next is the menu title. A menu's title provides the context for the current set of choices. The title must reflect the choice selected on the previously displayed menu. choice descriptions. Choice descriptions are the alternatives available to the user. These descriptions range from a numeric or alphabetized listing of choices to single words or phrases to full sentences or more. So the style chosen will reflect the experience of the user, the nature of the choices, the nature of the selection mechanism, and the nature of the system. So here, while giving the description for the choices, the user may choose uh, what to say, the user may be a novice, or he might be an expert, or he may be having a lot of choices based on his well-learned alternatives, and he may be using some choices for the keyboard or for the mouse while giving a description for the menus. And next is the completion instructions. This tells users how to indicate their choices. They may include the rationale for why the user is being asked to make this choice and the impact the choice will have on subsequent processes. So explicit instructions may be needed for first time or casual users of a system, but experienced users will find overly verbose instructions unnecessary. So here the needs of all system users and the nature of the system must again be considered in creating this kind of on-screen guidance. So here, if I am developing any application, first I should know for what context this menu has been designed and what is the title I have to given. So within that menu, what are the choices I am going to include, and description of the choices, so that the user, when he places the mouse on those choices, and information related to that choices has to be displayed. And completion instructions, that is how it tells the users to indicate their choices, which is being asked to make them choices and impact the choices which will have a subsequent processes. So here these are the four things which a menu possesses, that is the contents of menus. Thank you. Please don't forget to subscribe, like, share and comment.